I didn't notice you over there. Yeah, I'm Steven Duranty, here at Valparaiso University Senior Design Center, working with Team 72 Dolphins on creating a brushless DC motor pump. I'm one of the 3 electrical engineers on the team, along with 2 other mechanicals. And I'm here to just give a little bit of insight into what our project is all about.
Hey, I'm Jared Metz. I'm one of the mechanicals on the team, and I'm just kind of going to explain what the difference between our motor is and kind of the traditional pump you see. So in a normal pump, you'd have just one motor it's got a rotor and stator inside it, and one of those parts, electrical current goes through it and forces the other part to turn. So normally in a pump, you'd have this. The shaft would be connected to the impeller right there, and that would be rotating inside the pump. So the difference with our motor is instead of having that with the shaft going in, we're having the rotor and stator as 2 different parts. Just built the rotor into our impeller, built our own stator. We're going to separate it like that and then have that rotating inside there. So what that does is instead of having the shaft go through, the problem with that is there's an active seal you need around it, and those are pretty hard to make. So with ours, we just got this little thin sheet of plastic, and it's a non-active seal. It makes sealing off the system a lot easier.
Hey guys, I'm Dan Arnold. I'm the other mechanical engineer for our group. This right here is the overall assembly for our project. This part right here is the stator and the bobbin, which we manufactured, and most of the other objects on here were 3D printed. We ordered a couple things like this bearing right here, along with the magnets on the back of the impeller.
The 3D printing process begins with a drawing created on SolidWorks, which is then sized and formatted for printing. To ensure print accuracy, the printer software layers the 3D image to a resolution of about 100 microns per layer. Much like a standard inkjet printer, the 3D printer uses the same XY coordinates combined with the Z-axis to give the image depth. The bobbins were manufactured on a lathe and are made of nickel iron alloy because of its conductive properties. Here you can see how the mill slowly carves away at the bobbin to reduce heat caused by friction, which alters the chemical properties of the metal, giving it that cobalt blue hue. The stator core was manufactured on a drill press and is made of steel. The hexagon pattern being drilled into the core was drawn to provide grooves for the stator coils to be epoxied in. The spacing between the cores plays a vital role in how the electromagnetic fields are shaped as the system is powered. The tolerance of inaccuracy in DC motor parts is very small, so precision manufacturing is a must.
Our brushless DC motor has a 3-phase, 6-pole design. Each coil was wound by hand and has exactly 168 turns. It is controlled using a Texas Instruments technology known as Instaspin. This technology uses back EMF as opposed to Hall effect sensors in order to determine the position of the motor and excite the appropriate coils at the right time. This winding process had to be completed 6 times and monitored with great care to make sure each one was as symmetrical as the last.